learned last year. What we're looking at today are, well, it's titled Right Triangle Trig Ratios. Really, the main thing that we're going to focus on and try to get to and build off of is special right triangles. Does anybody know special right triangles? Do you guys have the slides opened or not? Okay, close, put your iPad flat down so you can't look ahead in the slides. There are two types of special right triangles. If someone can tell me one of those two, I will give them an extra credit point on the exam. I saw Aaron's hand first, then Cole's. Not quite. Cole.
Is it like there's a right angle and all the sides are the same?
Close, but not quite. Then I saw. I didn't see when your hand went up. Did it go before or after Trey? So Trey, then Faith, and then after Cole. So Faith, then Trey, then Smitty. No, okay, Faith. Not quite.
Scaling.
Not quite.
Right triangle.
Well, they're all right triangles. Yes, Aaron. Kind of, but we're talking about special right triangles have to do with the angle measures. Yeah, Caleb.
Equal angle.
No, because we have a 90 degree. Any other?
Oh,
yes.
It's like when one degree is 90 and the other two exact.
So what would that be then?
I don't know. I think they're 45.
Very good. So one of our special rights is a 45, 45, 90.
Oh my goodness. And one's a 30.
Then what is our other special right? So
Anything that's not 60, 60, 60.
I saw Aaron's hand. A what?
30, 69.
It's 66.
30, 60, 90 would be the other.
Attaboy, Trey.
So these are the two types of special right triangles that we are going to be looking at. Faith got the first one. And Trey got the second one. You're on fire with your guessing lately, Trey. So those are the types of triangles that we're going to be mostly. Aaron, it's okay. You were close. You were right there. You got it rolling, so that's all good. So that is the types of triangles we're going to focus mainly on. Now we will solve using sine, cosine, and tangent, other types of triangles, but what we want to get to is those special right triangles. So if you would have had me for geometry, here's the slide that you would have seen where you learn about tangent. Now, I was going to zoom through this, but I think it probably would be good to have a little review of tangent. So remember, ka, toa. So katoa, that's how we remember our trig ratios. Now, for this slide, what you would have started out in geometry learning is tangent. And the tangent ratio is opposite over adjacent. Yep. So if we are taking the tangent from the perspective of angle A, so from this perspective, give me the sides. What would the opposite side be? Well, there's no numbers here, so BC. What would the hypotenuse be? Oh, sorry. We don't want hypotenuse. Opposite over adjacent, but that would be AC. If we are taking the tangent from the perspective of angle B, what is our opposite? And the adjacent? Good. So it's all about what perspective we're taking the tangent from or taking the sine from. Now, on the next day of geometry, if you would have had me, we would have talked about sine and cosine. Remember, so, ka, toa. We already talked about toa. So if we look at sine, and if we go from the perspective of angle A, what is our opposite? Yep, and the hypotenuse is good. Now, if we're talking cosine from the perspective of angle A, what do we have then? Over AB, over the hypotenuse still. Okay? Is this semi-familiar? Am I blowing your minds right now? Okay. That's a good thing, I guess. So the big thing is, I mean, even if you guys aren't super familiar with these, we can set up our ratio and we can solve for either angle measures or we can solve for side lengths. And we'll look at some examples. I mean, this is what we're doing today. We're kind of building a foundation for what we are working towards. Now, again, our focus is these special rights. So there will be other examples, but I want to look at the special right triangles that we have here. So why don't you do what the directions say? Work with a partner, work with the person next to you, find the exact values of sine, cosine, and tangent for each of these. So I'll just show you what I'm looking for, like with sine. If we are finding the exact value for the sine from this 30-degree angle, what is the sine? What is the ratio for sine? What do we say it was? Opposite over hypotenuse. So 1/2 would be the exact value. Now if we do cosine from the 30-degree, what would our cosine be? Over 2. Now there might be a case where we have a square root on the bottom. Do we like square roots on the bottom? No, so we need to rationalize our denominator. Go ahead, work with the person next to you. Write these down, or someone around you, or you can work solo if the person that sits next to you isn't a good worker.
So do we just do the tangent for the first one?
So the first one you need to do the tangent, and then you would need to go from the 60-degree angle as well. So you should have 6. You should have 6 answers for each one. So there's quite a bit.
Nobody's trying to like kill people.
Guys, let's go. Get something done. Yeah. Which one are you doing right now? Okay, so tangent of 30 would be 1 over root 3. So then, and I'll put it up here because that probably will be helpful. We need to multiply by root 3 over root 3. That's how we rationalize the denominator. So root 3 times root 3 is just 3. 1 times 3 is root 3. So multiply it by that denominator. I don't know if you remember rationalizing the denominator. Does that sound familiar? Okay. There should be sine, cosine. There should be 6 for each one, because you don't need to go from the perspective of the 90-degree. So you'll have you'll have 9 total, because you'll have 3 for 60, or 3 for 30, 3 for 60, and 3 for 45. You following with me? You sure? Everyone's probably a little confused. You're writing sine, cosine, tangent from the 30-degree perspective. From the 60-degree, sine, cosine, tangent. And then you can go 45 twice, but it's going to be the same, right?
So you just put the 60 in where the 30 is?
Right. You're finding the sine in your 60-degree angle. Yep. And you're setting up the ratio. And do the same thing from 45 when you get over here.
So how do you get the bottom?
Down here?
Yeah.
What do you mean how I get the bottom?
Oh, okay, never mind. Well, let's see like the answer. Are we just setting it up or are we trying to find
Well, you're setting it up and then simplifying. So it should all be in fraction form. Sine, cosine, and tangent. And I'll slowly write them up there as I get them.
Shoot, I get it. 30.5. Oh my goodness.
There's nothing to type in your calculator here. You're just writing the fractions. Yeah. It's just like when we have, you can throw it in the basket. Like when we have, yeah, pretty much any clean numbers, 3 clean numbers, not decimals, not square roots, that come out clean, those are Pythagorean triples.
That's what I thought it was.
Yeah.
I actually had geometry
So that helps a little bit.
but I went from winter to winter for math.
That's a big gap. Yeah.
Like last year's second try. The last time I had math before this year's second try.
So I know it's a lot, and with not a solid foundation for most of us in geometry, this might be a little bit quick. And it's a big shift from what we've been talking about, right? What we've been doing has been very typical algebra. Yeah. Yep. Algebra E. That would be another good word. Now we are shifting towards, yes, geometry, but also a little bit of a different side of algebra. So we need to shift our mindset a little bit. These would be those ratios that we are setting up. And these will be ratios, I'm going to tell you right now. Maybe, I don't remember. No, it won't be in the next week. But once you get to FST, you'll work with these more. And you will have all of these memorized, like, very quickly. So these will be something that you'll get pretty comfortable with and get used to. But we're introducing them to you now. Are there any questions on any of how I got any of those? Were you able to work through those together? Okay. Again, the purpose of that was just to get you used to and remind you of sine, cosine, tangent, and also get you more familiar with those special right triangles. Now, we call them trig ratios, okay? And you already have talked about and know sine, cosine, and tangent. But those aren't the only trig ratios that exist. The other ones that we're adding to it are cotangent, secant, and cosecant. Now, let's start with cotangent. What do you notice about cotangent, about that ratio? Anything? It's the opposite of what? Yeah, it's the opposite of tangent. So if you take tangent, flip it over, then we have cotangent. What do we notice about secant? It's the opposite of cosine. Yep. So if we take cosine, flip it over, we have secant. So what we remember, kind of the saying that we use to help remember, is S goes with C, and we'll see that C goes with S. So if we look at those first letter, it helps to remember that cosine and secant are opposites. S goes with C, and that sine and cosecant are opposites. And C goes with S. And we'll get a little bit more used to that, but we know that they are just flipped over. So these are 3 new ratios that we are adding. And I don't think we'll do work with them in our practice, but you guys can look at these formulas and figure out ratios and all that stuff. Right, Levi?
That's right.
Okay.
Secant C.
No.
C.
So those are the ones that we are adding. Now, this will be a very typical homework question for today. Evaluate the 6 trigonometric fractions or functions of the angle theta. So remember, theta is just a cool way of saying from that angle. So if we have the 6 trig functions, here they are. So let's start with the sine from the perspective of theta is what? You guys, whoa. We got to first find the hypotenuse. Sorry. Somebody find the hypotenuse. Or everybody find the hypotenuse. Even better. Can we confirm? Somebody confirm. Confirm 13? That sounds good to me. 13? Okay. Now we can, thank you. Now we can give the sine from the perspective of theta. So sine is opposite over hypotenuse. Thank you, Cole. And cosine. Tangent from the perspective of theta would be opposite over adjacent. Yeah, 12 over 5. Very good. Now there's 3. Let's go with cotangent next. Would be just flipped over, 5 over 12. Now, which one of those ratios goes with cosine? Secant, right? Because C goes with S. And then which one goes with sine? Cosecant. And 13 over 12. So these new ratios that we're adding, not anything crazy, right? We already know sine, cosine, tangent. We're just flipping them over. The more difficult thing will just to keep these pairings together. How are we doing? Well, technically you don't have to keep them together, but just remembering that cosecant is the opposite of sine. You see, 12 and 13.
Why does that matter? Just so it's easy?
Well, it just makes it easier to remember it. Instead of remembering that cosecant is like hypotenuse over opposite, you can just remember that the sine flipped over. So maybe that's not easier for you. Maybe you want to memorize all the other ones. But if you can remember SOHCAHTOA, and that S goes with C and C goes with S, then we're going to be okay. No big deal. Is that all of our new learning for today? I think so. There's one thing that I'll show you because you're going to get on the big ideas assignment and be like, what the heck? I don't remember this. Even though you probably maybe should kind of remember. And let's see. If this was the question they had, they said solve for theta. Which trig ratio would we use? You tell me, with the information given, which trig ratio would we use? Someone said it. We would use sine because we only have opposite and we have the hypotenuse. Now, if they wanted to know how many degrees this angle was, how would we solve that? How do we solve for angles? Who remembers? They do, but we have 2 missing angles. Yeah? If we wanted to know how many degrees it was, that angle. You could use a protractor, yes. If you didn't want to, do you guys remember sine inverse? Oh no. You guys never learned sine inverse?
I remember the name.
I think so. We use the inverses. Sine inverse is how we solve for angles. So if this is our setup right here, sine inverse undoes sine. So we can say that theta equals sine inverse of 7 over 15. And we can punch that in our calculator and get a number. Instead of hitting sine, then you hit sine inverse and then go with it. Yeah, I just made up the number, so it's probably not going to give you something legit. Like this might not even be a good triangle. But you're going to have practice on it on your assignment. So if you don't totally remember, you will. Make sure your calculator is in what mode? Do you know? Not quite. Degree mode. We do not want to be in radiant mode. Oh, you were in radiant? Okay. But your hit mode. hit mode and go for, I think the fourth one down. Yeah, and you have to highlight, hit enter. You want to be in degree. Most of you should be in degree because geometry took a test this morning on the trig ratios and had the calculators. Hopefully, degree. Yeah, you're good.
Yeah, you're right. How are you?
That's the only thing you have to note today. Really, technically, a review of geometry and that's not even ratios. Yeah, right. Okay, perfect. Go ahead, log on to BIM and
Bim.
BIM.
Do we just